Hi, I'm Nipun Agarwal. I manage the MySQL HeatWave team, and today I'll be talking to you about MySQL HeatWave Lakehouse, which is a recent announcement. MySQL HeatWave is a fully managed MySQL database service from Oracle, and it is the only MySQL database which provides support for transaction processing, analytics, and machine learning. So customers now have the advantage that they don't need to move their workloads to different services to get good performance for running analytics or machine learning. So customers can keep all the data in MySQL, and they can run all their existing tools and applications for transaction processing, for analytics, and for machine learning without having to make any change to the application, because we have enhanced the MySQL engine to support these new new capabilities for analytics without requiring any proprietary syntax. So the capabilities customers get is a fully managed service, which is built, managed, and supported by the MySQL development team. It's a single database for analytics, OLTP, machine learning, and it is significantly faster than the best of breed services. We have support for in-database machine learning, where the machine learning training is 25 times faster than Redshift ML. And it has support for MySQL Autopilot, which provides machine learning-based automation for various aspects of the service. Now, MySQL HeatWave was GA in late 2020. And since then, we have had a lot of customer momentum. So we have a lot of customers who are using MySQL or MySQL-based databases, or customers who are not using MySQL, customers who are using Teradata, customers using SAP HANA, customers using Redshift. So we have a lot of customers who have been migrating their application from existing databases, from open source version of MySQL, from other clouds to MySQL HeatWave. And the main reason they are doing that is because it's a single database for running multiple workloads. It's very performant, very inexpensive, and there is no change that customers need to make to the application because it's all standard MySQL. So because of this, we see a lot of momentum from customers. Now, although it's good to have a single database which provides support for various workloads, the question is that are customers giving up something in terms of performance or in terms of cost when they're using MySQL HeatWave? So what this performance result is showing is 4 terabyte PPCH workload. We did a benchmark comparing MySQL HeatWave with the performance of Redshift, Snowflake, Google BigQuery, and Synapse. What is interesting is that the data all resides inside MySQL database, where customers can run other workloads as well, including OLTP, machine learning. But for analytics, MySQL HeatWave offers 23 times better price performance compared to Redshift, 35 times better price performance compared to Snowflake, 41 times better price performance compared to Google BigQuery, and 15 times better price performance compared to Synapse. Now, the scripts for all of these results of HeatWave are available on GitHub for anyone to try, download, or even modify them to see what will be the performance advantage of HeatWave on their workloads compared to any other database offering. Right? So not only is it a single database, not only does it have machine learning-based automation, but it is also much more performant and offered a much lower cost. And as a result, it provides significant price performance advantage compared to other services. Now, for OLTP workloads as well, MySQL HeatWave is very attractive because compared to the other services, let's say RDS MySQL from Amazon or Azure MySQL or Google Cloud SQL, MySQL HeatWave is offered at a fraction of the cost, at 1/3 of the cost. It has more capabilities than this version of the SQL, or the version of MySQL, which these are the cloud services are running, because MySQL HeatWave is built upon the enterprise edition of MySQL, whereas what the other cloud vendors are running is the open source version of MySQL. So customers have the benefit that they get more capabilities with MySQL HeatWave for OLTP, and it is offered at 1/3 the cost. So even for OLTP, it's very attractive. And then when it comes to machine learning, MySQL HeatWave is the only database which has in-database support for machine learning. Unlike Redshift ML, all the data and the model always stays inside MySQL HeatWave. Data is never sent to another service for running machine learning. So the data is inside the database. The training is done inside the database. And the interesting aspect is that we have fully automated the training process, right from pre-processing of the data to selection of the algorithm, to selection of the feature, to the hyperparameter tuning. All of this thing is done completely automated. And in addition to this, we also have support for explanations for all the models which are generated by HeatWave ML. So it's completely automated, which is very good for database users because they don't need to now worry that they need to work or consult the database scientists for running machine learning on top of the data inside MySQL. But it is also very performant. On an average, HeatWave ML is 25 times faster than Redshift ML. And the reason is because we have come up with new algorithms for the training process, which are very parallelizable. The second aspect is HeatWave ML is run on the existing HeatWave cluster. There is no need for users to provision a different cluster to pay for some other service. In the case of Redshift, customers need to go, or like the system basically invokes Redshift from Redshift ML. It invokes SageMaker, and there's additional cost for the users in the case of Redshift. So with MySQL HeatWave, customers get the ability to do machine learning processing inside the database, fully automated, much faster, and at no additional cost. Now, this is all great and fantastic. And what we have been hearing from customers is they would like to leverage MySQL HeatWave for doing processing of data which is not inside the database. Because databases are the systems of record, right? And the most valuable data for people is stored inside databases. But there's a lot of data which is being generated from various devices, from sensors, from IoTs, right? And this data typically does not reside in a database. It resides in an object store or some other storage format, which people refer to as data lake, right? So the characteristics are it's a lot more data. The data may not be structured. And what customers have been asking for is the ability to leverage MySQL HeatWave for data which is outside the database. And that's exactly what we are going to be talking about today. So what we have done is we have enhanced MySQL. So we started with MySQL, which was designed and optimized for transaction processing. Then we added support for HeatWave, which is designed for scale-out processing for analytics and for complex queries. Then we added support for machine learning inside HeatWave. And now what we're doing is we're providing all of these capabilities to data which resides outside the database in an object store. So the data size could be much larger. The data format could be different. It could be a CSV format. It could be Parquet. It backups from Amazon Aurora, backups from Amazon Redshift. So customers can now run query processing on the data which resides outside the database. In addition to this thing, they can also run queries which combine data from the database with a file in the object store. So it is possible that you have some transactional data which is residing in the database, and you want to join it with data which is in a file in the object store. This is now something which is now possible with MySQL HeatWave Lakehouse. So leveraging all the benefits, all the scalability aspects, all the automation aspects of MySQL HeatWave, but now providing it to data which resides in object store. So a unified engine for transactional processing, analytics, machine learning, and now data on data lake. It provides the ability to query data across the MySQL database and an external source. MySQL Autopilot, which provides machine learning-based automation, has been enhanced for Lakehouse. HeatWave now provides a scale-out architecture, both for data management as well as query processing. So the size of the HeatWave cluster can now be up to 512 nodes. And finally, this is fully compatible with the MySQL syntax, which is based on standard SQL syntax. So this is an example. You can see it's fully SQL standard SQL, and users can now, for instance, do a join of a relational table inside the database with the file which is stored in the object store. Now, the first thing is the capability that yes, we can process data which is in the object store residing in a variety of formats. But what is the performance of this? And what is the cost of this compared to other services like Redshift or Snowflake, which have really been built and designed around processing data in the object store? So what we are showing over here is on a 400 terabyte workload running TPCH queries, on an average, for these, the average of the 22 TPCH queries, HeatWave takes 42 seconds to return the result. Redshift takes 268 seconds to return the result. And Snowflake takes over 700 seconds to return the result. And the cost of the cluster is more expensive both for Redshift and Snowflake compared to HeatWave. So for HeatWave, the cost comes to about $1.6 million. And for Redshift and Snowflake, it's about $2.2 million, the annual cost. So HeatWave is less expensive than other services. It is much faster than other services for data which resides outside the database. So the net is price performance advantage. It's about 6 times lower price performance compared to Redshift and about 16.5 times better price performance compared to Snowflake. So this is for query performance. Now, when you have this large amount of data, it is important to also look at the load time. Like how long does it take to read the data from the CSV file into the system, whether it's HeatWave or Redshift or Snowflake, before starting to run queries. What we find is there again, HeatWave has the best load time. We can load 400 terabytes of data in a CSV format in about 4 hours. Redshift takes 32 hours. Snowflake takes 11 hours. So what you now see is that HeatWave provides all the functionality we have been talking about in the past: transactional processing, analytics, machine learning inside the database. It can also now do processing outside the database on much larger data sets with the price performance which is better than both Redshift and Snowflake, both for query processing as well as for data load. Now let's talk about some of the other interesting characteristics of MySQL HeatWave Lakehouse. The first thing is we wanted to make sure that the performance of HeatWave, whether the data is residing inside the database or outside the database, is the same. So on the left-hand side, we are showing two data sizes, 30 terabytes and 10 terabytes TPCH, and the average query time is the same, whether the data was inside the database or outside the database. On the right-hand side, what I'm showing is that on two different data sizes, 10 terabytes and 400 terabytes, the price performance advantage which HeatWave has over Snowflake is also about the same, which means that both on smaller data sizes as well as larger data sizes, HeatWave offers significantly better price performance compared to other services. And one of the reasons we are able to do that is because at runtime, HeatWave is able to dynamically adapt the algorithms depending upon the data characteristics. Now, one of the things which has been very important for MySQL HeatWave, and it has very much been the case even for Lakehouse, is MySQL Autopilot. So MySQL Autopilot provides users with machine learning-based automation, which is workload aware. And we have a lot of capabilities in MySQL Autopilot, which helps user automate the system setup, loading of the data, processing the queries, handling of the failures. And we have now enhanced MySQL Autopilot with various capabilities which are interesting and relevant to the Lakehouse case. So these are 6 examples of capabilities we have added. I'm going to talk in a little bit of more detail with examples on a couple of them. So let's talk about the first one, which is the auto schema inference. When the user has some amount of data in a CSV file in the object store, the first question is, or the first task which any user needs to do is to define the mapping of this file for which the structure is not necessarily known to the corresponding like schema definition. With auto schema inference, this Autopilot automatically determines what is the appropriate data type, what is the size of this data type or this column, and whether it has nulls or not nulls. And the reason it's able to do that very efficiently is because it does an intelligent sampling. So instead of scanning the entire data set, which can take a long time depending upon the data size, MySQL Autopilot does intelligent sampling. In addition to that, it can also determine whether the schema into which this table is being loaded is present or not. And if not, it issues the appropriate commands like the create database command or the create table command. The second capability is auto provisioning. With auto provisioning, Autopilot determines for the user what is going to be the size of the data when it is loaded inside HeatWave. Because HeatWave is an in-memory engine, and when we load data, we compress the data. And the size of the cluster, which is the cost of the cluster, is determined based on how much of memory the data is going to take. So Autopilot, even before loading, just by sampling, is able to determine that, okay, this 100 terabytes of data is going to take 61.78 terabytes of in-memory representation. It is also able to estimate the load time. Like in this case, it's giving you a sense that it's going to take about 1.98 hours to load the data. So all of this information is available via Autopilot, which comes in very handy for the customer. And then the third interesting feature which we have developed for Autopilot is what we call adaptive data flow. Now, depending upon the region you're running your service in, depending upon the specific, like, bucket, the object store bucket you have, the performance characteristics of the underlying storage may vary, right? So the bandwidth which you get, the number of requests per second which are served, right? This is something which may vary. What HeatWave does is that it determines what is the maximum performance that is available for that specific bucket, for that specific region, and it makes requests and optimizes the system for that maximum available bandwidth and throughput. As a result, customers always get the best performance out of their cloud infrastructure. And this is a lot more important when you have much larger data volumes, right? Both for load as well as for query performance. Now, one of the things which I showed you is that our load performance is really good. Now, in the past, when we have talked about MySQL HeatWave, we have provided details as to why is the query processing, the scale-out query processing for HeatWave so efficient. And the same techniques have been enhanced for the Lakehouse case. But loading is interesting because it's the first time we are loading, like say, 400 terabytes of data into HeatWave, and we find that we are faster than Redshift and Snowflake. How did we do that? Well, there are a number of techniques we developed. One of them is what we call super chunking. So we take the input data and we partition it into fine-grained chunks. And then when the chunks come in, HeatWave does a dynamic allocation to assign these chunks to the specific workers or the cores which are going to process the data for load. And the reason this dynamic allocation is very useful is because the amount of time it takes to process each of these chunks may vary depending upon the data type or other data characteristics. It can also vary depending upon the latency at that specific moment in time. So the combination of super chunking and dynamic allocation gives customers a very good load performance. Now, so far the results I've been showing have been for loading data, which is in a CSV format. Let's see the performance of loading data in a Parquet format, because Parquet is a very popular format. A lot of people use it. And the interesting thing about Parquet is that the Parquet layout of the representation is very similar to the HeatWave in-memory representation, which is a hybrid in-memory columnar representation. So it's very similar. So what we're able to do is that as we read the Parquet files, we're able to transform them and load them into the memory of HeatWave very efficiently. So what I'm showing over here is 10 terabytes DPCH data size. Both for CSV and Parquet, we take about 2 hours to load 10 terabytes on a cluster size of 12 nodes. So both the formats we can load in about the same time. Aurora Backup, which is also stored as a Parquet, we can load in about 7 hours. And what is interesting is we can load Aurora Backup into HeatWave faster than what Redshift can load an Aurora backup into a Redshift cluster. The second observation I want to make is about the query performance. Once the data has been loaded into HeatWave, regardless of what the source file format was, whether it was CSV or Parquet or Aurora backup, the query performance is the same. And the third observation I want to make is that the load process is now scaling out pretty well. So for 400 terabytes, I'd show that it takes about 4 hours to load 400 terabytes on a larger cluster. 10 terabytes we can load in about 2 hours. Right? So we increased the size by 40 times, but the load time increased only by 2 times. Right? So it means that the load processing also scales quite well with MySQL HeatWave. Now, to summarize, MySQL HeatWave provides support for transactional processing, analytics, and machine learning. It's a single database which provides support for all these workloads. MySQL HeatWave provides better performance, better price performance compared to other services. And the other services you are comparing are Redshift, Snowflake, Google BigQuery, Azure Synapse. The capabilities which we talked about in MySQL HeatWave have now been extended to support processing data which is in the object store. And this can be much larger data sizes. It can be in a variety of file formats. And users now have the ability that they can run queries which cut across data in the relation database as well as a file in the object store. And finally, this is a service which is being developed, managed, and supported by the MySQL development team. So customers will always be on the latest version of the enterprise edition of the MySQL database. And with this, I invite you to try the beta of this service, which is now available. And we welcome your feedback and comments. And thank you for your time.